A very common thing for a programmer to want to do is to allow the user of their software to input text via the keyboard. And in this video, I want to talk about cin, which is the basic object or feature of C++ that we use in order to do that, to get text-based input from the keyboard. Now, this isn't to say this is the only way that a C++ programmer can do this kind of thing, but this is usually where people start, is by learning how to use the cin object. So I am assuming at this point that you're already familiar with the cout object and how that works. And so I'm going to kind of leverage that assumption. Cin is a lot like cout, except that things are going the other direction. So here I'm modeling cin as a simple machine with a button and a tray. And in this case, the button has on it a symbol or a pair of symbols, right-facing or right-pointing chevrons that indicate something we refer to as the extraction operator. And so if we hit this button on the machine, the idea is that cin is going to try to read information. It's going to try to read characters specifically out of the buffer, this input buffer, and format those characters properly to go inside of whatever the variable is that I have placed on this tray. Okay, now where do the things inside the buffer come from? In this case, they're going to come from the keyboard. So by default, cin is going to be trying to read from a buffer that's attached to the keyboard. Okay, so when we type things and we hit enter, those things don't immediately go into our program. They go and they first sit in the buffer, in this buffer, until our program asks for them. All right, so let's look at some example code that does just that. So this simple program is called simpleinput.cpp. I'm including IOStream and string so that I can work with the cin object and also work with string objects. Makes it a lot easier to deal with words and sentences and so forth. Again, I'm referring to a previous video I made about cout, but in this particular program, I have created some variables that I'm initializing to an exclamation mark, the word unused, and so forth. The real meat of this program that I'd like to talk about is down here, where I have several cout statements wrapped around a cin statement. And so here you see me actually trying to use this cin object. And so I reference cin, I reference the object, and then I use the extraction operator to say that I'd like to pull out from this buffer, in this case, something to put into hr. And hr is a character. And so when I that's kind of like saying I've put then this hr variable on this tray and hit this button. And so cin can see this variable and knows what its type is. And so it's going to try to say, OK, I need to put a character in there. And it's going to try to find a character in the buffer. A little further down, you see me do that with a string, and then also right here, an integer. OK, so in each of these cases, cin is going to try to take the information in the buffer and fulfill the request to either read a char, a string, or an integer. Now, this is significant because perhaps maybe not intuitively, when we're typing in numbers on the keyboard, we're not actually generating numbers. What we're generating are characters. So for instance, if you look at your keyboard, there is a 0, a 1, a 2, and so forth. But when you hit those keys, what goes into the buffer is not a 0 and a 1 and a 2 in terms of digits, but rather a character that looks like a 0 and a 1 and so forth. And so normally, without the help of cin, if we were to get a hold of that information, those characters that had been typed, we'd have to manually say, OK, these are the digits they've typed, and we'd have to do the math to then convert that into an integer or a floating point number that the user is trying to represent. Cin does that for us, or at least it tries to. It tries to look at what's in the buffer and do that transformation for us. So if it sees a 1 and a 0 and a 0, and then it'll look at that and say, oh, that's trying to represent the integer 100, if it's the case that we're trying to read those characters into a variable that's an integer. So I hope that makes a little bit of sense. All right, let's go ahead and compile this program, run it, see what it's doing, and then we'll talk about more of the details. All right. right, so again, I called this simple input. There we go, .cpp. And we'll run a.out. The executable is generated. OK, so it's asking me to enter a character. I'm just going to go ahead and I'll enter the character A. That is not an A. That's an A. OK, enter the character A. So it's echoing back. We see here I said, please enter a character, cin a char, and then I output the string you entered followed by the variable and then a new line. So you entered A. Now enter a string. I'm going to go ahead and type my name. OK, and then an integer. I'm going to go with a 2. Print it back out, and then a double. We'll say a 2.1. OK, so this kind of works as we might expect. So that's the basic usage of cin and the way that we would then read in values that we can use later in our program. I'd like to show you, though, some of the things that can go wrong as you're working with this particular object. Or perhaps not wrong in some cases, but maybe that might surprise you. So I typed the letter A, and then I hit Enter, and then I typed Frank and hit Enter, and so forth. This time around, I am going to simply type a word when it asks me for a character instead of just one character. And then we're going to look at what happened and talk about it. OK? So let's rerun this. Please enter a character. So I'm going to, instead of typing just a character, I'm going to type Fred and hit Enter. OK, now we see you entered F, and certainly there was an F that I typed, and that is a character, so it makes sense that it would take that F and it would put that into this variable HR. However, what might surprise us is to then see that when it asks then, please enter a string, I didn't get to type anything else. And it came back and said, you entered red. Now there's a hint here. If we look up here at Fred and take off the F, we get the word red. And so if we look back at our image, our diagram of how this actually works, we can get some understanding in terms of what just happened. So when it asked me for a character, the program had executed up to this point. It had executed up to this point where we printed that string, and now we're trying to read in HR. OK, so we've effectively smashed the button with HR sitting right here on this tray. And cin looked in the buffer, and it couldn't see anything useful. And so it's just sitting there waiting for something to pop into the buffer that it can use to satisfy this request for a character. So when we typed Fred and hit Enter, the characters, let's make sure I've got this highlighted. Yeah, it looks like it. OK, there we go. So the character F, R, E, D, that is not a D. Let's fix that. D. And then the new line were all placed in this buffer. OK, now again, the program had already reached this point and was trying to get something out of the buffer. So we hit Enter, and it was populated then with these characters. So cin immediately then said, all right, there's a character. I needed one of those. And so it reads this F out of the buffer, and it's going to take it out of the buffer and stick it into that variable. And so I'm just going to delete that cell. I'm using a spreadsheet to mimic this behavior here. So I delete the cell, and we see kind of everything pops up in the buffer. So now the thing at the top of the buffer is the R, the RED, what's left of Fred. All right? So we satisfied cin's request for a character. Then we said, hey, please enter a string. And then before we could do anything, it read what was in the buffer. It saw that, hey, there's already stuff there, and so it tried to satisfy the request. Now, this does a couple things. A, it surprises us because we didn't realize that the the leftovers from this string we're going to end up in our variable. Also, it makes our output look kind of funny over here because now you entered, let's pull this into focus. You entered red, showed up on the same line with please enter a string. Why did that happen? Well, earlier when we input a character and hit enter, that enter not only caused the input that we generated from the keyboard to go into the buffer, but it also caused the shell here to generate a new line when we hit the enter. And so that put us on the next line for the output. That didn't happen here because I didn't get to hit enter again. And so that's why it kind of messed all that up. Okay? So hopefully you're seeing then that understanding what's actually happening here can help us to understand what's happening over here. So that's one thing that can get kind of weird. Here's another thing that can kind of catch you off guard and cause issues. We've asked the user to enter an integer, but what if they don't? What if they think they're being funny and they type out the word 5? Okay, so I hit enter and all kinds of bad things happened. It said, you entered 0. No, I didn't. But that's what it's telling me. You entered 0, and then it says, please enter a double. You entered 57. So we're seeing something similar to what we saw up here, where CN went ahead and did something kind of quote-unquote without me, having a chance to respond. Let's try to dissect this and understand more about what's actually happening. So let's come over here. We need to update our image here. This is showing what things looked like just before the string was read in. And so actually we've now already read all of these characters up to the new line. And I'm going to talk about that in a moment. That's an important thing. What do we have going on there? I just need normal delete. Can I get it? Yep, delete cells. Okay. So the buffer's nearly empty. It has a new line in it when we reach this point that says, please enter an integer. Okay, now this is a great opportunity to talk about one of the other things, or rather one of the other important behaviors of CN. CN kind of does things in phases. When we ask for something, such as a char, the first thing that CN will do is look in the buffer, and it knows there might be white space. And white space is anything like a space or a tab character, or in this case, a new line. And so when we've asked for something, CN says, you're not looking for white space. You're looking for something that's been typed, a word, a number, this kind of thing. So the first thing it does is it gets rid of any white space that it sees on top of the buffer. So it just takes those things and throws them away. So when we reach this point where we've tried to read an integer, that's what it's going to do. It's going to say, all right, I'm going to get rid of my white space that I'm seeing, because I know we don't want that, especially we don't want that inside of an integer. Okay, so it kind of cleans house, and in this case then there's nothing left. So now the buffer's empty, so we're sitting here waiting to read an integer. So phase 1 for CN was get rid of white space. Phase 2 is read the thing that I've been asked for. Phase 3 is stop. How do we know when to stop? When we see white space again. Okay, and then that white space will be left, just as we saw that it was before. Now, so here we are, we're waiting for an integer, and that's where we created a problem over here. We typed 5 and hit enter. So let's put that in the buffer. I'll come to this side. Okay, and we'll put that in the buffer. So the characters F, I, V, E, and then once again a new line because I hit enter. So these are the things now, these are the characters, excuse me, sitting in the buffer. And then we hit the read in an integer part. So CN is trying to take the characters it finds here and convert those into a number. So when it saw earlier that we typed a 2, it saw the 2 character and said, yep, that's a digit, and so I can convert that into the numeric representation of a 2. And so it does that. Now, it could have been a larger number, 2, 6, 7, for 267, in which case it would have read the 2 and checked to see if it could keep going. Oh yeah, the next thing is a digit. So it would consume all those digits and then try to convert that into an integer and store it in our variable. In this case, though, it didn't see a digit. It saw the character F, and it immediately choked. Okay, now CN kind of acts like a person who's choking. So you've heard that if somebody's choking or if you think they're choking, you're supposed to ask them, are you choking? And of course, if they can answer yes, then you know they're not really choking yet. And you want to give them a chance to see if they can cough up whatever it is that they're about to choke on, okay, before doing something drastic like the Heimlich. Now, so maybe saying that they're not choking isn't accurate, but they don't need the Heimlich yet. Now, CN behaves in a similar way then. It chokes on this thing that it's trying to read. It's not able to take it in and turn it into a number. And so it kind of grabs its neck here and it falls down on the floor and just sits there, okay? And it doesn't do anything. It's not throwing an error we can see or anything like that. It doesn't do anything to actively tell us something has gone wrong. But what it's going to do now, as someone who's on the floor choking might do, is it's going to ignore requests. Okay, so it fails to read in a number as we asked it to, and then when we come down here, sorry, I'm not even showing that code. Let's scroll up. You'll notice the next set of statements is asking for a double and trying to read that in, and so when we reach that point, CN is still in this failed state. It's still plugged up. And so instead of reading in a double, it just silently ignores us and the program goes on. So in the case of the integer where we tried to read the integer, you see that we started with the integer value at 42, and when it failed, it stuck a 0 in it. But it's still in this failed state when we reach this point, and it ends up just leaving the variable alone. So it doesn't even change it, and so that's why we appear to being told that we put in a 57. Well, that's just because it says you entered, and then we printed out the value of the double, and it hasn't been changed, and so that's why we see the 57. All right, so this is a frustrating thing for beginning programmers to see all this weirdness happening, and so I wanted to make sure you were aware of some of the things that can go wrong. Now, what can we do if that happens and CN is plugged up and it's on the floor choking? There are things that we can do to help it out. We have to go through a process of turning off the error and getting the thing out of the way that's causing the problem. That's beyond the scope of this video, but I will cover it in another video. So for now, I think this is a pretty good foundation for you to begin working with CN on, and so we'll just leave it there until next time. Thank you.